Okay, number 15. For the reaction HCl plus NaOH yields NaCl plus H2O, which reaction is the limiting reactant given 100.0 grams of sodium hydroxide and 100.0 grams of hydrochloric acid? Okay, so this is a limiting reactant problem, which means you pick a reactant to be A and reactant to be B. Okay, so because sodium hydroxide is listed first, I'm going to use that as my reactant A, which is going to be my given. So 100 grams of NaOH. And the unknown, I'm going to try and figure out how much hydrochloric acid I need to react with that. Okay, so in this problem, it's slightly tricky because you need to know that this is hydrochloric acid and you need to know that this is sodium hydroxide. You know that it's asking for reactants, so you know you can look on the side of the equation. And then from the words, you should know that sodium means that it has to be this one. And this says hydrochloric, which means it's got hydrogen and chlorine in it, so you should know that that's your hydrochloric acid. Then the whole point of a limiting reactant problem is you go from the mass of one reactant and you try and figure out how much the other one you need, and then you compare that back to the mass that you're actually given in the problem. And that then can tell you which one is limiting and which one is not. If the number that you get doing all of the stoichiometry is less than the number that you're given in the problem, then that means that you don't need as much as you have and it's excess. If the number that you get doing all of the stoichiometry is bigger than the number that you have up in the problem, then that means that you need more than you have, so it is the limiting reactant. Okay, so going ahead and trying to do our mole map here, we know that we're going to go from grams of sodium hydroxide into grams of hydrochloric acid, and that means that we have to go to moles of sodium hydroxide first, and then into moles of hydrochloric acid, HCl, and then we can go to grams of hydrochloric acid. So, of course, this is a three-step conversion. Our first one is going to be molar mass of the sodium hydroxide. So 1 mole of NaOH equals blank grams. We have to calculus 1 times sodium, 1 times oxygen, 1 times hydrogen. So that's 1 times 22.990, 1 times 15.999, and 1 times 1.008. So all of these are just the same numbers, because anything times 1 is itself. And you need to add them all up, and you get 39.997. So we put that in our blank, 39.997 grams of sodium hydroxide. And then we need to do our mole to mole ratio. So blank moles of sodium hydroxide equals blank moles of hydrochloric acid. So that gets us from moles of sodium hydroxide into moles of hydrochloric acid. We look up here at our equation. This equation is balanced. We have 2 hydrogens on this side. We have 2 hydrogens on this side. We have 1 chlorine and 1 chlorine. We have 1 sodium. We have 1 sodium. We have 1 oxygen. We have 1 oxygen. So even though there's not any coefficients on this, it just means that all of our mole to mole ratios are 1. So this is 1 mole to 1 mole of hydrochloric acid. And then the last step is we're right here. We're trying to go from moles of hydrochloric acid into grams of hydrochloric acid, which means we need to do another molar mass. So 1 mole of HCl equals blank grams of HCl. So that's 1 times hydrogen, 1 times chlorine, that's 1 times 0.008. Remember, you get these masses from the periodic table. 1 times 35.453. So that's just the numbers added up, 1.008 plus 35.453. And when you add those together, you get 36.461. Okay, so at this point you're ready to do your equation. This is a 3-step. So we're starting with grams of sodium hydroxide. we're trying to get into moles of sodium hydroxide, and then into moles of hydrochloric acid, and then the last step is to get into grams of hydrochloric acid. And then you need your units to cancel, so if you've got grams of sodium hydroxide on top, you need it on bottom. So that's grams of sodium hydroxide. We go to our next one, we've got moles of sodium hydroxide here, which means we need the same thing on the bottom. Moles of sodium hydroxide. And then we've got moles of hydrochloric acid, we need moles of hydrochloric acid on bottom. Substituting in our numbers, we're given 100.0 grams of sodium hydroxide. Molar mass is always 1 mole of the substance, so 1 mole of sodium hydroxide is 39.997 grams of NaOH. Remember, we're getting these numbers from these equivalent statements we wrote up here. 1 mole is to 39.997, 1 mole is to 39.997. So our mole to mole ratio is 1 mole of NaOH to 1 mole of hydrochloric acid. So these are both 1. 1 mole of HCl is 1 mole of NaOH. And then the last one is our molar mass of hydrochloric acid. So 36.461 grams of hydrochloric acid is 1 mole. So 36.461 grams of HCl is 1 mole of HCl. So math-wise, what are we doing? We're taking the 100, we're dividing it by 39.997, and then we're multiplying by 36.461. Remember, you can ignore all these ones because anything multiplied or divided by 1 is just itself. So you get 91.1593 on the calculator. And then the last step is to do your significant digits. So our given has 4, the mass has 5, mole to mole ratios are exact, and this number has 5, so we need to take our answer to 4. The 9 rounds the 5 up. This becomes 91.16 grams of HCl. This is what is needed. Okay, so then you compare your needed back up to what you were given, 100 grams of hydrochloric acid. All right, so 91.16 grams of HCl is less than the 100.0 grams of HCl you were given. So if needed is less than the given, then that means it's in excess. So our hydrochloric acid is in excess, which means the sodium hydroxide is the limiting reactant. And that's what it asks us for.